we do, I just won't assess it. So if we end up doing rates of change, it'll just be for your own knowledge. I won't actually assess you on that unit. So basically, this will be your last unit, your last assessment unit. So we still have to do the assessments for Unit 6, and then these last assessments for Unit 7. And your CPT will probably be, I want to say, the week after next week. So yeah, you do need it for calc, so that's why I'm going to teach it to you, but I'm not actually going to assess you on it. So yeah, so today we're going to do 7.1 and 7.2. If we finish early, we finish early. I'm pretty sure you guys aren't going to complain if we finish early. But yeah, so what we're going to do is we're going to start off with logarithms. Honestly, if you remember all of your exponent laws, logs will be very easy for all of you. Okay, so we're going to start off with the first example, just to be fresher on exponent laws. So lesson 7.1 is exploring the logarithmic function. So we want to recall the exponent laws. So when we're multiplying exponents with the same base, we're adding the exponents. So what would the answer be for 3 to the 4 plus 3 to the 5? 3 to the power of 9. Okay, and then we have, when we divide exponents with the same base, we have to subtract the exponents. So we get 5 to the 17 divided by 5 to the 13. What would that give us? 5 to the 4. And then we have the power rule. So when we're applying a number with an exponent to the power of another exponent, all you're doing is multiplying the exponents together. So what would 2 to the 5 to the power of 3 give us? 2 to the 15. And then when we have a negative exponent, we just have to take the reciprocal of it. So if we have a to the power of negative n, the reciprocal would be 1 over a to the power of n. So if we take 2 to the power of negative 3, what would that look like? Thank you, Jose. 1 over 2 to the 3. And when we simplify that, what does that give us? One over 8. And last but not least, we have a fraction to the power of a negative exponent. So all you're doing is flipping that fraction over, and the exponent turns positive. So we get a over b to the negative n is equal to b over a to the power of n. So we get b to the n over a to the n. So we have 2 over 3 to the power of negative 4. And we just have to flip the fractions over. So we get 3 over 2 to the power of 4. And what does that give us? So we get 3 to the 4 over 2 to the 4. And what are our values for 3 to the 4 and 2 to the 4? We get 81 over 16. So there's also one more thing that they forgot to mention in this rule. So if we have a root, let's just say we have a to the m over n, that just simplifies to m root a to the power of n. So when we have an example of that, so I'm going to give you guys an example. So let's say we have 9 to the power of 1/2. Okay? If we have 9 to the power of 1/2, the 1 is our n, the 2 is our m. So this is just equal to 2 comma 9 to the power of 1, which is just the same as saying the square root of 9. So the number m, in this case, identifies what type of root it is. So because it's a 2, it's a square root. If it's a 3, it would be a cubic root. If it was a 4, it would be a quartic root. If it was a 5, it would be a quintic root. So is everybody on par with all of this so far? It's pretty basic stuff for now. Like I said, logs is not going to be hard. This should be probably the easiest unit out of all of them, simply because it just involves exponent laws and graphing. So when we have the exponential function y is equal to b to the x, b is greater than 0, and b cannot equal to 1. So give me an example where b has to be greater than 0, but b is bigger than, cannot be 1. Okay, we'll do b is equal to 4. So we're going to look at y is equal to 4 to the power of x. So we're going to have 3 points. So remember, what does any number to the power of 0 give us? 1. So when x is 0, y is 1. So our y-intercept when the b value is positive is always going to be 1. And then we continue sub, I'm just going to make a table of values on the right. So this is y is equal to 4 to the x. So when we have 0, we have 1. When x is equal to 1, what is our y value? So when x is 1, what is our y value? 4. Okay, when x is 2, what is our y value? 16. How about when x is negative 1, what would our y value be? One over 4. So as you can see, graphing exponential function is pretty straightforward. So we're just going to plot the points. Obviously, I can't plot 2 and 16 because it goes beyond the scale. So you have 0, 1, 1, and 4. And then we have negative 1 and 1 over 4. So that's probably going to look something like that. And then all we're going to do is connect our lines. Okay? So when it comes to making money and finances, this is everyone's favorite type of function to look at. Can anyone tell me why? Because there's always going to be a big increase, okay? And when it came to last year's grade 11 functions course, what concept in the financial unit best represented the exponential function? Let's see if you guys remember this. You were supposed to have a financial unit in grade 11. So if you skip that, the best possible concept that represents an exponential function in finance is the concept of compound interest when it comes to an investment. Okay, so looking at this exponential function of y is equal to 4 to the x, what would our domain be? So our domain would be XER, because x can be any x value. Since if we have a negative x value, it just throws us back a fraction at the end. What would our range be in this case as well? So YER such that y is greater than 1. Thank you, Adam. Not greater than 1, but greater than 0. What kind of asymptote do we have? Do we have a horizontal or a vertical asymptote? So we have a horizontal asymptote at y is equal to 0. So for our range, our y value can be 1. What the restriction was talking about in the question was what our base for that exponential function was. And last but not least, what is our y-intercept? So our y-intercept is going to be 1. Okay? Now let's take a different example. Let's look at the graph. Y is equal to 4 to the negative x. Without making a table of values, how would y is equal 4 to the negative x look like in comparison to y is equal 4 to the x? Think about your transformations from the polynomial unit. Okay, decreasing, that is technically correct. But what kind of transformation do we have? Not in the x-axis, but it's reflected in the y-axis. So remember, the reflection in the x-axis is if the negative is before the base of the exponent. So if it was a reflection in the x-axis, we would have y is equal to negative 4 to the x. But because the negative happens to be in front of the x, it is a reflection in the y-axis. So our y-intercept still remains the same. However, negative 1 becomes 4, and 1 becomes 1 over 4. And we still have the same domain and range. So does the concept of log seem hard so far? All right, let's move on to our next example. Or not next example, but our next concept. So the definition of the logarithmic function is as follows. So the log function is the inverse of an exponential function. So if we take the exponential function y is equal to b of x and interchange the x and the y variables, we get the inverse. So x is equal to b to the y is called an exponential form, and y is equal to log b to the x is called the logarithmic form. So these things are the same, but written differently. So this new notation is read the log of x to the base of b, and is introduced in order to isolate for the inverse for y. X is called the argument of the logarithmic function. So we're just going to take a little bit of an example, and we'll actually do examples together. So the answer to the logarithm is the exponent needed on base b to give you the value of x. So for example, we have log of log base 2, 8 is equal to 3. The reason being is because 2 to the power of 3 gives us 8. So this will all start to make more sense once we start doing examples. So we want to write this in exponential form. So we have log of base 3 to the 9 is equal to 2. So how would we write that in exponential form? So it's just 3 to the 2 is equal to 9. So all we're doing is we have the form log bx is equal to y. When we want to put it in exponential form, all we're doing is we're taking b to the y is equal to x. So let's see if you guys can solve the next one. So we have log of 1/2 8 is equal to -3. So we have 1/2 to the -3 is equal to 8. Just to be safe, we're just gonna check to see if it's right. So because it's a negative exponent, we're gonna flip the fraction. So we get 2 to the 3 is equal to 8, which means 8 is equal to 8, which means that this holds true. And now the next one we have is log of root 5, 25 is equal to 4. We did change it into a positive exponent because we had 1/2 to the -3 is equal to 8. In order to make that -3 positive, we just flip the fraction. So we get 2/1, which is the same thing as 2. Then we get 2 to the 3 is equal to 8, and 8 is equal to 8. So yes, the next one is 5 to the power of 4/2. So let's just start step by step. So we get root 5 to the 4 is equal to 25. We get 5 to the 1/2 to the power of 4 is equal to 25. And then when we have exponent to the exponent, we multiply. So we get 5 to the 1/2 times 4, which is just 2, is equal to 25, which gives us 25 is equal to 25. So as you can see, just by the definition of a log function and exponential function, we can change it from log form into exponential form. And the next question, we're going to take it from exponential form and turn it into log form. So let's just remember we have b to the y is equal to x. that is exponential form, and that turns into log of b x is equal to y. So the next example is we want to write it in log form. So we have 4 to the power of 3 is equal to 64. So how would we write that in log form? So log 464 is equal to 3. Perfect. What would our next one look like? We have 2 over 5 to the negative 2 is equal to 25 over 4. Yep. So you have log of 2 over 5 of 25 over 4 is equal to negative 2. And last but not least, we have 3x is equal to y. So how can we change this from exponential form into logarithmic form? So we have, thank you, log 3, y is equal to x. So is it easy to change it from exponential to log and from log to exponential? Okay, so give me 2 seconds. Bear with me. I'm just going to take attendance first. Oh, so my night school class did their first quiz yesterday, the same quiz I gave you guys, and only 2 people got perfect. The class average for that quiz was, I believe, 7.8 from what I remember. So the class average was 78 for that quiz. It was the Unit 1 quiz, so the one with the domain and the range questions. Does anybody know if Sarah forgot there was class this morning by any chance? If someone can message her saying that we have class now, same with Rashtina, that is also greatly appreciated, guys. Because I'm guessing they forgot or they either slept in, one of the two. So we're going to move on to example 3. So for example 3, we want to evaluate each of the following exactly without using a calculator. Okay? So even though we don't have an answer, all of these are equal to a specific x value, and it is our job to solve for what x is. So we have our first example. We have log 381 is equal to x. So if you were to change that into exponential form, how would it look like? So we would have 3 to the x is equal to 81. So in order for us to solve for x, we need to find an exponent to the base of 3 that gives us 81. So we have 3x is equal to 3 to the power of what? So 3 to the power of what gives us 81? 4. So you have 3x is equal to 3 to the 4. And because everything has the same base, so both the left side and the right side have the base of 3, we can just ignore the 3's and just focus on the x. So we get x is equal to 4. Which means if you were to write this out again, we get log 381 is equal to 4. Did everybody understand that example? Okay. Now we're going to move on to the next one. So we have example B. We have log of 1/3 and 243 is equal to x. So first we need to transform it into exponential form. And what would that look like? So we have 1/3 to the x is equal to 243. So we're going to focus on the denominator, okay? So this is the base we want to come up with for our right side number. So we have 1/3x is equal to 3 to the power of what number? So so 3 to the power of what exponent gives us 243? Five. So we get 1/3x is equal to 3 to the 5. Is this fine or do we have to do one more step? Okay, so we need to get this 3 into a fraction. We need to turn into 1 over 3. So how do we get 3 to turn into 1 over 3? And Jose, is that it? We're going to make the 5 into a negative exponent. So we got 1 over 3x is equal to 1 over 3 to the negative 5, which means our final answer is what? X is equal to negative 5. Which means when we write this all out again, we get log base of 1 over 3. 243 is equal to negative 5. All right, let's keep going. So we have log of base 7 times the square root of 343 is equal to x. How would we write this in exponential form? So how would we write example C in exponential form? Seven to the x is equal to root 343. But because we're working with exponents, we can just write 7 to the x is equal to 343 to the power of 1 over 2. Now what we need to do is find out if 343 can be written with an exponent with a base of 7. Is that possible? Thank you, Bozola. 7 to the power of 3. So we got 7x is equal to 7 to the power of 3 to the power of 1 over 2. And remember, when we have an exponent to the power of an exponent, we're going to multiply. So what does the right side simplify into? Three over 2. 7x is equal to 7 to the power of 3 over 2, which means our x value is going to be 3 over 2. So when we write this again, we get log of 7 root 343 is equal to 3 over 2. And then our last example we have is we have log to the base of 8. 1 is equal to x. How do we write that in exponential form? So a to the x is equal to 1. And just based off our basic knowledge, what is the only possible number that gives us a value of 1? A to the 0. Which means x is equal to 0. So when we rewrite our log form out, we get log of 1 base 8 is equal to 0. All right, so as you can see, this isn't too bad. I think you guys should have a pretty easy unit 7. So when we're graphing the log functions, the general shape of the graph of the log function depends on the value of the base. So if b is bigger than 1, both the exponential function and the log functions are increasing. If b is a fraction, so between 0 and 1, both exponential functions and log functions are going to be decreasing. So we're going to graph some logarithmic functions. So the first one we have is 3 to the power of x. So we're going to type in all our x values, and then we're going to have our y values, and we're going to write its inverse. So based off of the definition, when we have the exponential form, what is the inverse of the exponential form? It's in the definition on the first page. So the inverse would just be the log function. So it would be y is equal to log of x to the base of 3. So let's start with the exponential function. So if we have a x value of -2, what would our y value be? So 1/9 or 0.1. The next one is going to be 0.3. Then 1, 3, and 9. So when we talk about an inverse function, what happens to the x value and y values of the normal function? They are switched, okay? So we're taking the same values, except our x values are going to be the y values from the parent function, and the y values of the inverse are going to be the x values from the exponential. So we get 0.1 and -2, 0.3, -1, 1 and 0, 3 and 1, and then 9 and 2. So now all we're going to do is graph both of them. So the red one is going to be y is equal to 3 to the x. And then our inverse one will be described by the green graph. So we get 1 and 0, 3 and 1, 9 and 2, 0.1, all right. So let's look at the exponential function. What is the domain of the exponential function? So our domain is going to be XER. Our range is going to be YER such that y is greater than 0. Do we have any x-intercepts for the exponential function? Nope, so this is not applicable. What is our y-intercept at 1. So you have y-intercept at 0 and 1. And what kind of asymptote do we have, or horizontal or vertical? No, we don't have a vertical asymptote for 3 of x. We have a horizontal one. So you have a horizontal at y is equal to 0. All right, now we're going to take a look at the log function. So for our log function, what would our domain be? Remember, it's the inverse of the exponential function. Yep, so what would the domain be for the log function? XER such that x is greater than 0. So what you're going to notice is the log function, so the domain, so the range of the exponential is going to be the range of the exponential is going to be the domain of the log, and the domain of the exponential is going to be the range of the log function. And also you're going to notice that the log function has a x-intercept at 1 and 0, but it has no y-intercept. And instead of a horizontal asymptote, the log function has a vertical asymptote. So is everybody okay with that one? Perfect. And then the last example is going to be pretty much the same thing as we did already. So we're just going to go through it pretty quickly. So the example we have is y is equal to 1 over 2 to the power of x, which means our inverse function is going to be y is equal to log of x to the base of 1/2. So again, we're just going to plug in the x values into the equation and see what y values it gives us back. So the first one, we have -2. So we get 4, 2, 0, 1 over 2, 1 over 4. And like we said, the inverse is just the x and y values switched from the exponential function. So we get 4 and -2, 2 and -1, 0 and 0, 1 over 2. Sorry, this should be 0 and 1. That was my mistake. All right, so basically by not even graphing it, would the domain and range be the same from the example? Would everything in the chart be the same from the example above? So everything, thank you, Adam, everything in this chart would be the same information as we use from the example above. So the domain is still XER for the exponential. The range is YER such that y is greater than 0. there is no x-intercept, there is a y-intercept at 0 and 1, and there is a horizontal asymptote at y is equal to 0. And then with the log function, it's just everything switched. So XER such that x is greater than 0. Then we have YER as our range. We have a x-intercept at 1 and 0, no y-intercept, and we have a vertical asymptote instead of a horizontal asymptote. So just some key things to remember. The domain of the exponential function is the range of its inverse log function and vice versa. The y-intercept of the exponential function is the x-intercept of the log function. And the x-axis, so y equals 0, is the horizontal asymptote of the exponential function. And the y-axis, x is equal to 0, is the vertical asymptote of the log function. So is everyone okay so far with the first lesson about the basics of log functions?